So today we're going to talk about natural logs and the number e. And our learning target is I can solve natural log equations. So just like when you talk about in previous math courses that like this is the Greek letter pi and it stands for 3.14 blah 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 forever, the number e also has a number it's associated with, and that's what we're going to talk about. Okay, so what is e? E is an irrational number, means that you can't make it into a fraction, that's what irrational means, with an approximate value of 2.718281828, and then that 1828 goes on forever. So this is called the number E after this man right here. Yes, I know, ladies. Try to control yourselves. But this is Euler, and he is a huge deal in mathematics. If you're never going to go on and become a math major or a science major, you're probably never going to care about him. But he's a big deal, does a lot of cool stuff. And e is often the base of exponential and logarithmic functions that describe real-world scenarios. So this number occurs naturally, and it occurs in so many places in nature and science, and I could go on and on forever. So here's the thing I think that sucks about math is that we just do like the boring parts of it, and then you go over to science and you see how it works, and it's like, oh, cool, labs and stuff. And so math is just blah. So sorry about that, but it is useful in real life. Maybe not to your life, but in somebody's, big time. Alright, so first thing we're going to do is we're going to look at this exponential and we're going to find the inverse. So this is y equals b to the x. So in the little blue box, if you have forgotten how to find the inverse, it's okay. Number one, we're going to switch x and y. That's the first step whenever you're doing this. Let's see. So x equals b to the y. And then you want to isolate y. So the only way to get y out of an exponent is to switch it to its opposite form. So it is in exponential form right now. The opposite of exponential form is log form. So if you have forgotten, the base of the exponent becomes the base of the log, and these two things switch places. So log base b of x equals y. And this is why we say logarithms are inverses of exponential. And that's what we talked about in our previous unit. This is exponential, and this is log form. And they're inverses of each other. Okay, so today, what we're going to talk about is something called a natural log. So, when you have e to the x, that is called a natural base. So the inverse of e to the x looks like this right here. Log base e of x. And we don't like that in math, so we abbreviate it like this. And that is called natural log. Sometimes you'll hear people call it LN, because that's what it stands for. But it's referred to as a natural log. And I can't remember why. It's something to do with Greek. It's something to do with like the Greek letters and how you pronounce them, and I forgot, so sorry. Okay, so if you're looking at your TI-84 calculator, you have a natural log button built right in. So there it is. It's a capital L, capital N on your calculator. But usually when we write it in math class, it's just a lowercase l, lowercase n. And then the button E, if you'll push the second button and then the natural log. So it's kind of hard to see, but it's right there. It's right above the ln, and you'll see an e to the x power. And that's how you find it. Okay, so if you don't have a calculator, it's cool. Go to Desmos. Anytime you want to do an e in the calculator, you just type it. So notice how I put y equals e, and it gave me that 2.718281828, blah, 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 forever. Alright, and then if you want to get to the natural log button, if you'll hit the little keyboard button, and then there'll be a button functions, and if you go all the way over to miscellaneous, the natural log button is right there. So, it does not matter if you have a TI-84 or if you're using the Desmos calculator, they're going to do the same things. Okay, So we're going to look at solving equations with e in them and solving equations with natural log in them. So step 1, make sure e or natural log are condensed and isolated. So here's what I'm talking about. I want the e and the exponent to be by itself. So the first thing I'm going to do is I'm going to get rid of the plus 3. I get rid of plus 3 by subtracting. Anything you do to one side, you got to do to the other. Okay. Alright, the next thing I need to get rid of is the 2 in front of the e. The 2 and the e are being multiplied, and you get rid of multiplication by dividing. So e to the x minus 9 equals 12. Alright, so we have isolated the e part. Alright, so number 2, convert to the opposite form. If it's in natural log form, we're going to change it to e. If it's in e form, we're going to change it to natural log. Alright, so here's what we're going to do. We're really taking the natural log of both sides, because natural log and e are inverses of each other. Okay, so the way you get rid of an e is you do the natural log. When we do the natural log and an e right beside of each other, these cancel each other out. The only thing that'll be left is the exponent. Okay. Hopefully that made sense. Alright, and then that was part 2. And then the last thing we're going to do is solve for the variable. Okay, so the natural log of 12 is a number. All you got to do is evaluate it. So either using Desmos or a calculator, I want you to type in natural log 12 and give me at least 4 decimal places. I got 2.48, let's do 49 equals x minus 9. And then the last thing we're going to do is get x by itself. So we got rid of that minus 9, and we would just add it. So our final answer is going to be 11.4849. Yeah. And that's what you do pretty much every time. So let's look at a different one. So notice this time we have the natural log. Okay, still the same steps. First thing we're going to do is make sure e or natural log are condensed and isolated. So what I want you to notice is that these are just numbers. Okay, there's no variables in them, there's no letters. I'm going to type this into the calculator and use at least 4 decimal places. Okay, so I had to round up to 3 decimal places, but we're good. Okay, so the whole point of this is to get this part by itself. I want to get that part by itself because that's where the variable is. So, if you think about this natural log being a number, we can go ahead and put that in our calculator. So go ahead and put the natural log of 6 in your calculator and use at least 4 decimal places. Okay, so here's what I have right now. I still don't have that natural log x plus 2 isolated, but I can get rid of the 1.7918. It's positive, so I'm going to subtract it from both sides. Alright, so I got 3.8712 equals the natural log of x plus 2. Alright. So I have gotten the natural log part isolated, which is what I wanted to do. There's no more numbers or anything to move around. Okay, so step 2, I'm going to convert to the opposite form. So if it's in natural log, we're going to change it to the e form. So here's what we're going to do. And this is a little weird, but this is just how you write it. So I'm going to write e to the power of 3.8712 equals e to the power of natural log x plus 2. Because anytime we I'll say e both sides, when you do that, it's e to the power of whatever was over that side. Okay, so the nice thing about this one is whenever you have an e and a natural log beside each other, they cancel out. So the only thing that's left on that side is the x plus 2, the exponent. This part right here, we just need to evaluate in our calculator. So put that in your calculator and give at least 4 decimal places. Alright, and that one is so close to 48, I'm going to call it 48. Alright, so we did step 2, check. And then the last step, step 3, we're going to solve for the variable. So we're going to get x by itself. The only thing we need to do is get rid of that plus 2, so we're going to subtract 2. So 46 equals x is our answer. Okay, so I know that was a lot, but it's the same process whether you have e or whether you have ln. And just remember that they're inverse of each other. So I'm going to give you one to try. So I want you to try to solve for x and pause the button in 1, 2, 3. Okay, first thing we got to do is isolate this part right here. So I'm going to get rid of that minus 6 by adding. So I got e to the x plus 3 equals 30. Check. The next thing I need to do is convert to the opposite form. So notice it is already in e form, so I'm going to take the natural log of both sides. And anytime I have a natural log and an e beside each other, they cancel each other out. Alright, so the only thing I have left is the x plus 3 on the left side, and then the natural log of 30. So now I need to evaluate natural log of 30. Alright, and then one last thing, subtract that 3 from both sides to get x by itself. And I got x is equal to 0.4012. Alright, so hopefully you got that too. If not, email me. Or remind me. Or, do whatever. Contact me. That's what I should say. Alright, I want you to try this one. So pause the video in 1, 2, 3. So the first thing I see that we can do is get rid of this natural log of 9. So I'm going to go ahead and evaluate that. Alright, so I evaluated it, and now I'm going to get rid of the minus 2.1972 by adding it to both sides. So I have the natural log of x equals 9.1972. Oh, sorry. The next thing I need to do is change it to its opposite form. So because it's in natural log form, I'm going to change it to the e form. And remember, anytime you do it, it's like e to that power, whatever was on that side. And anytime an e and a natural log are beside each other, they cancel out. So the only thing left was be the exponent. Oh. Got too fast, sorry. And then this is just a number, so all we gotta do is type e to the power of 9.1972 in our calculator, and we're done. And it's a big number, but don't be scared. I'm gonna run out of room. I'm gonna put a 9. Okay, so that is 9,869.4559. That's your answer. A big answer, but don't be scared. Sometimes they're big answers. Alright, we're done with this video. Contact me if you need extra help.